This is a square cone. The picture on the left is showing cannons that are sweeping across one side, one flat of the square cone. And that's an angled fan jet. It kind of takes the cannon, elevates it a little bit above the port so material's not coming back into the valve assembly. And we sweep across those flats, and that stops the material from arching and bridging from one side to the other and keeps the material going. On the right side is another square cone. It's a little bit shorter in its height, but we have just a blowpipe in the center kicking out the bridging material. That's right above the discharge to the bell. So knowing exactly where our arching material is, where the buildup is, we can place cannons in that material, kick out its foothold, and we can do it a couple different ways. Both of these work, and both of these get the job done. Sometimes we have to shear the flat, and using the one of two styles of a cannon blast, a fan jet flat profile blast or a round blowpipe for just the brute force of knocking out bridging material. This shows both of them getting the job done for the information that we receive about the buildup problems and the problems of no flow conditions.
Well, that's a good point. So the nice thing about the air cannon world is one specific nozzle works well, and then another specific nozzle works well as well. It really depends on the type of material that you have and the moisture content, but basically the versatility of how we attack it is crucial to your production.